Hi everyone. Today we are going to learn about Gram-Schmidt process, which is used to find orthonormal basis and orthogonal basis for a vector space. I think all of you know how to find basis of a vector space. So for that, we need to find today orthogonal basis and orthonormal basis for a vector space. So what does it mean, orthogonal basis? A basis which is orthogonal set, that is called orthogonal basis. And orthonormal basis, what does it mean? A basis which is orthogonal set of a unit vectors, that is called orthonormal basis. Now let us see how to find orthogonal basis and orthonormal basis of a vector space by using Gram-Schmidt process. So it is used to find orthogonal basis or orthonormal basis for a vector space. Let capital V be a vector space and B equals to, suppose, x1, x2 and so on, xn be a basis for V. Be a basis for V. Now, how to make this basis as orthogonal basis by using Gram-Schmidt process? Let us see that. Let we take one more variable as C. C equals to small v1, small v2 and so on, vn be a orthogonal basis for V. For V. So in Gram-Schmidt process, step 1, here we have to make this x1, we have to find orthogonal vector to this x1. This va1 is the orthogonal vector to this x1. First let v1 equals to x1. Next v2. We need to find orthogonal vector to x2. That is v2. So we know orthogonal projection of x2. According to that, we will write this formula as v2 equals to x2 minus x2 dot v1 by v1 dot v1 into v1. Like this, we will write v3 also. v3 is the orthogonal vector to x3. So v3 equals to x3 minus x3 dot v1 by v1 dot v1 minus x3 dot v2 by v2 dot v2. Like this, we will continue this process up to Vn. So Vn is the orthogonal vector to Xn. Then Vn equals to Xn minus Xn dot, we have to write these projections up to Vn minus 1. So like this, V1 by V1 dot V1 minus Xn dot V2 by V2 dot V2 minus and so on, continue up to Xn dot Vn minus 1 by Vn minus 1 dot Vn minus 1 into Vn minus 1. By using these formulae, we will find V1, V2, V3 up to Vn. So try to remember this formulae. Now let us discuss one example. See, one example. Let W is equal to span x1 comma x2, where x1 is equal to 360, x2 is equal to 122. Construct an orthogonal basis V1 comma V2 of W. This is our question. Now let us see how to find orthogonal basis. By Gram-Schmidt process, what is given here? W is equal to span x1, x2. It is here x1, x2 is nothing but spanning set of W, and also we will observe x1 and x2 both are linearly independent vectors. So when x1 and x2 spanning set and linearly independent, we can take it as basis of W. So given W be a subspace of V and B is equal to x1 comma x2 be a basis. These two are given. Now we need to find orthogonal basis for W. We have to construct orthogonal basis for W. How can we construct? We know the formula for orthogonal basis. So let orthogonal basis for W be V1 comma V2. So what is V1 is equal? X1. X1 is equal, it is given 360. Now what is V2 formula? V2 equals to x2 minus x2 dot V1 by V1 dot V1 into V1. So for this just we need to find x2 dot V1 inner product. Find inner product of x2 dot V1. We know x2. What is x2? 1, 2, 2. 1, 2, 2. Dot V1. What is V1? Here V1. 360. 360. So do inner product. How can you do inner product of two vectors? Transpose of this first vector 1, 2, 2 into 360. So if you do inner product, it will be 1 into 3 plus 12 plus 0. So finally it is 15. Next find V1 dot V1. V1 dot V1 equals to, we know V1 dot V1. V1 is 360 dot 360 is equal, transpose the first matrix, column matrix 360 into 360 is equal 3 3s are 9 plus 6 6 are 36 plus 0. So it is 45. Now we got all the values, substitute in V2. So I will write here V2 equals to x2. We know x2 1 2 2 minus x2 dot V1 is 15 by V1 dot V1 is 45. 45. What is V1? This is V1 360. 360. If you simplify, it will be 1 2 2 minus 15 3s are 45. So it will be 3 by 3 1, 6 by 3 2, 0. So finally it is 0 0 2. We got V2. Now what is our orthogonal basis? Orthogonal basis. Orthogonal basis for W is equal V1 comma V2. So here we got V1 as 3 6 0 and V2 as 0 0 2. So like this we will find orthogonal basis for the given vector space. Thank you.